Okay, now we go into how we want to prepare solution from the main solution that you prepare from the standard chemicals. Okay, this slide before, okay, this is the one that I show how we do stock solution, just like how we prepare like stock syrup. Okay, and then you want to dilute the syrup to make several glasses of drinks. This is the same thing in chemistry. So this is for stock solution using powdered chemicals. Okay, if it's powdered, powdered lah. If it's liquid, liquid. Powdered chemicals. Okay, and then from the stock solution, how do you want to dilute to make individual concentration? 1 ppm, 2 ppm, 3 ppm kan? 1 ppm over here until 3 ppm, the one that you want. Okay, so we use M1 V1, M2 V2. What is M1? What is M2? So M1 is the concentration of the original solution. Okay, this is stock solution. Stock solution. M2 is the concentration of the solution that you want. Okay, this is the one that you want. For example, if your stock is 10 ppm, for example, then this is the one that you want. Okay, M2. And then V1. V1 is the volume of the original solution, and V2 is the volume of the desired solution. Okay. Usually, what we want to find is this one, V1. How much from the stock solution you want to take to make the desired solution. Okay, from color itself, you can see 100 molarity will be diluted to 10, 1, 0.1, 0.01, and then the color will reduce, just like how you prepare a red syrup. Okay, M1, V1, M2, V2. Okay, do we have examples? Okay, no, we don't have examples. For example, M1, you have 10 ppm. Okay, 10 ppm. V1 is the wanted. M2, you want 1 ppm. And you want to prepare 1 ppm inside 50 ml. Okay, means that V1 is 50 times 1, 50, then divide by 10. So your V1 is 5 ml. So you have to take 5 ml of the stock inside this volumetric flask to make 1 ppm. As simple as that. Okay, usually in chemical analysis we have worksheet to do this. Okay, you can develop your own worksheet. Is actually not rigid, and as long as you understand, that's your own worksheet. Okay, but if you want to do research later and you would like to ask me on how to do this worksheet, how to like make into like understandable column and everything, you can find me, and then we can work from that. Okay, for the sake of this subject, I will cover on that because it's a standard. Okay, after you have your standard solutions, minimum in chemical analysis you have to have 5 standard solution. Okay, so you already have 1 ppm, 2 ppm, 3 ppm, 4 ppm, and 5 ppm. What should you do? You go to the instrument and inject one by one and record the signal. It is signal, okay, of this 1 ppm of standard solution. Okay, and then you run your sample denoted as X. Okay, as I said just now, if your sample you run into the instrument, instrument said that the signal I get is around 0.17. That is the signal for X. So what is the concentration? You can either extrapolate. Okay, you can either get like 2.9 ppm, but it's not easy to extrapolate when you have soft copy graph, right? So what you can do is you go in, this all can be done in Excel, and in Excel you have the function of doing calibration curve, and in calibration curve function you can set the YMX plus C equation. Okay, and then from this YMX plus C you can also set what is the regression coefficient of regression. Means that how well this line is meaning a good chemical analysis. Anything that moving towards 1 means that's really good. It's really linear. Okay, the one that we usually want in chemical analysis is 0.995. When you get 1 is sometimes we don't believe the data because, come on, we have errors in doing solution, right? So anything 0.995 or 0.99678 is okay. Okay, so we will see how the R square, bad R square looks like later. Okay, from Y mx plus C, how do you want to analyze concentration of X from Y mx plus C? X is concentration, right? Y is signal, right? So it's easy. Okay, I mentioned just now. Okay, sorry. Y, the equation sometimes will 0.5x plus what is the slope? Sorry, slope. So, apa ni? Benda ni. Intercept. Okay. 0, for example, 0.001 is really nearing 0, kan? So you want to know what is x. Okay, so you take your equation just now. Y is equal to 0.17 because it belong to x. 0.7, 0.5 times x plus 0.001. So you will get x. Okay, so imagine je lah x is 2.9 ppm. Okay, so you can do this calculation of Y mx plus C in worksheet as well. As easy as that. So this is how R square, the regression coefficient of regression nearing 1 looks like. It's really good. Okay. Is this acceptable? Okay, 0.9962. Okay, this is acceptable. Just now I said you should get 0.995 and above. Okay. And then, is this acceptable? 9809. Okay, let me tell you. Okay, according to IUPAC and also APHA, sometimes APHA, EPA, AOSC, like make statements. Okay, if you are working at a very trace level such as PPB, okay, or low ppm, R square that is acceptable can be lower than what we usually use. For example, 995 is the one that we want, right? But when you are working with trace level, sometimes this R square is acceptable. What is the reason? Because at trace level, it is really hard to maintain the accuracy because they are very tiny. Okay, means that when you pipette the solution, if you drop like very nanoliter amount of standard solution, there goes your result. The error will be high. Therefore, this standard method sometimes accept this R square. Okay, so when you want to present your data in court next time, okay, you may be be challenged on why are you presenting a chemical analysis having this 0.9809 as R square? Isn't it unacceptable? If you refer to this method, okay, based on APHA method, EPA method, it stated that if the analysis is done in trace levels such as PPB, it is acceptable worldwide. Then your data and your evidence, everything may be accepted in court. Okay, you will learn on how to defend all your data, everything with Dr. Najib or Dr. Afiq later. In chemical analysis, it is less, it's not less serious, but it is less less prone to be rejected, because in chemical analysis in general, we usually work with QA/QC, and then we usually work with environmental monitoring. So sometimes having this kind of R square is okay, because we based on this standard method. Okay, so before I go further, I want to discuss on this point. Okay, minimum to have 3 points. Okay, but the best is to have 5. Okay, 1, 2, 3, 4, 5. This is not counted because this is blank. Blank means that there's no analyte inside your matrix. Okay, but you have to run blank so that you know the instrument is okay. For each of this point, this 1 point represent 3 replicates. Okay, means that if you run 1 ppm for 3 times, you get average of data, right? Then you can put inside this graph. If you only put 1 data, it always will be challenged. Okay, you have to replicate this concentration, this also. So when we say that we are doing calibration, usually it will take several days because we repeat a lot. This is repetition within a day, and then we repeat the whole graph for 3 days. Okay, this is all outlined in this standard. Okay, how many days you have to do? Sometimes 3 days. If in forensic, maybe 10 days. I don't know. If it's in EPA, it's usually 3 days. Okay. The more serious the data to be used, means that in court and everything, the more high accuracy and high repeatability it want to know. Okay. And then we have like 2 types of calibration curve. Okay, just now the previous video I showed you the external calibration graph. Means that, what is the meaning of external? Means that we have 5 standard solution. External means that the sample is inside the 6 volumetric class. Okay, we have blank. Blank is compulsory for any calibration curve. So this is blank. This is 1 ppm, 2, 3, 4, 5, and your sample. So this is the meaning of external. External method, meaning that your sample is not inside your 1, 2, 3, 4, 5. Okay, this is the most common method. Okay, because we prepare and analyze the standard separate from the sample. This is most convenient for a large number of similar sample. Okay, if you have, for example, 100 samples, okay, by doing only 1 calibration curve, okay, YMX plus C, by doing only 1, you can have signal from 100 samples and then just use YMX plus C here and then calculate your X. Okay. However, please bear in mind that in order to use external calibration graph, you have to make sure your sample is 100% clean. Okay, when you do 100% clean sample, then you can do external method. How to get 100% clean? By doing sample preparation. Okay, now it makes sense why you need to focus on sample preparation, because you want to use external method. Okay, what if you cannot have clean sample? You already do a lot of things, you try everything, and still you can see a lot of peaks inside a chromatogram. Don't worry. We have another method. We call it as standard addition calibration method. Okay, we will look into it later. Okay, but now I would like to finish up on the external first. So you can read on your own. External method is usually used for clean sample. And clean sample means that there's no matrix. What if you have matrix inside it? Your matrix will be giving signal as well. Isn't it headache? Okay, so that's why we need clean sample. Okay, I already show you how to do this. You can read on your own later. Like this, YMX plus C, everything.